All right, here we go. The last example I did in the quick notes that I gave you was one that I wanted to do more justice to. Because typically, we're not just going to give you a limit of a ratio with a radical function in the denominator. We want to know, does it have a horizontal asymptote? That means two things. One, what is the limit as x grows without bound of f of x? That's the first thing I have to ask myself. And two, what is the limit as x shrinks without bound of f of x? Now I need a little bit of algebra here. So I'm going to just work on the denominator separately so that I can show you some algebra techniques. So the first thing I do is I'm going to, at least this is how I handle it, I'm going to factor my radicand. I believe that's 1 plus 2 over x squared. Please do this with me. Now from Algebra 1 in geometry, the square root of a product is the product of the roots. And I bring it to this. Now, I'm doing both of these at once. So the square root of x squared will be the absolute value of x. Okay. Now let's do case 1. What is the limit as x grows without bound of f of x? By the substitution property of equality, that's the limit as x grows without bound of 3x plus 1 all over, that will be positive x, over 1 plus 2 over x squared. Okay, I'm going to divide everything through. I'm going to multiply the numerator and the denominator by 1 over x. Well, you can see how this is going to go. Yeah, here we go. The limit as x grows without bound, 1 over x times 3x plus 1. I'm going to pull that up like that. Okay, now I'm going to distribute it. So as x grows without bound, that becomes 3 plus 1 over x, and then my denominator, 1 plus 2 over x squared. Now I'm ready to go do this thing. This is the limit of a quotient, which is the quotient of the limits. In the numerator, that's the limit of the sum, which is the sum of the limits. The limit of a constant is a constant. But as x grows without bound, 1 over x goes to 0. In the denominator, this is the square root. 1 plus as x grows without bound, 2 over x squared, well, that goes to 0. What's 1 plus 0? I hope it's still 1. And the square root of 1, I hope it's still 1. And 3 over 1 is 3. So on the right, we have a horizontal asymptote of y equals 3. The interesting part happens what occurs on the left. That's kind of cool, actually. So on the left, we have the limit as x shrinks without bound of f of x. By the substitution property of equality, this is the limit as x. Now it's almost like what we did before, except for one thing. We have a 3x plus 1, but in our denominator, to get rid of the negative, or the absolute value, I introduced the opposite of x. Now I'll go over that again in a second. That's because, recall, the square root of x squared is the absolute value of x, which is minus x if x is negative, and positive x if x is 0 or larger. And that's what we have to use here. And it's mind-numbing if you haven't used it before. Now, I'm going to factor the negative 1 out because I can. And now it's this exact same problem that we had before. So this will be negative 3. Whoa, 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 Mr. Isaac, you're telling me I have two horizontal asymptotes, one on the left and one on the right? Ooh, yeah, baby, you do. And it's cool, isn't it? Hold on one second. Let me get a graph. So as you can see, I was busy this morning. I made a graph. Here is what this thing looks like, and it's kind of cool actually. I hope this helps. This is posted on the YouTube channel, and I'll send a link. I'll put a link inside the folder. See you tomorrow. Bye-bye.